So how would you find the complement and supplement of pi thirds? Oh, wait. Okay, complementary angles add up to 90 degrees. Supplementary angles add up to 180. But wait a minute. All that's out the window because we're not in degrees, right? Well, it's not all out the window, but the units are out the window. So here's another situation where we can draw it to really understand what's going on. So, and I'll probably end up drawing this picture a couple of times. So if our terminal side of our angle coincides with the initial side, in other words, along the x-axis, then that's 0 degrees, which is the same as 0 radians, right? What if your terminal side is is in the direction of 90 degrees? Well, we already talked about how that's got to be pi over 2. And if you do the conversion, just multiply 90 by pi over 180, it'll reduce to pi over 2. And then what about the straight angle? So in other words, that angle would be 180 degrees, which is pi. That's our conversion. That's where we got our conversion factor from, right? What about 3/4 of the way around? The terminal side is 3/4, so negative y-axis, 3/4 of the way around. We know that that's 270 degrees, which is 3 pi halves. Multiply 270 by pi over 180, it will reduce to 3 pi over 2. And then if you go all the way around, it's 360 degrees. Right now, we don't want to say equals. We want to say coterminal. So I won't put an equal sign here. But if you go all the way around, that's 360, which is equal to what? 2 pi. But again, I'm not saying 0 degrees is equal to 360, but they are coterminal, right? There's a big difference between a 0 degree angle, no angle at all, and a 360 degree angle going all the way around, right? The big difference. But they are coterminal. So, okay, so what are the two angles going to add to? Let's call them alpha and beta. If they're complementary and we want to be in radians, what are they going to add to? Not 90, but pi over 2. And if they're supplementary, what do alpha and beta add to? Pi, pi. The straight angle, 180, which is in radians, it's pi. Oh, okay, so now you can figure it out. What if you want the complement of pi thirds? What would you do? So, yeah, what would you do with pi over 2? The complement would be pi over 2. What would you do with that? Minus pi thirds. Can we combine that into a single fraction, maybe? We need a common denominator, right, to add or subtract fractions. So what is the common denominator? So we would multiply pi thirds by 2 halves, right? Oh, we're multiplying by 1 again, right? 2 halves. That's the conversion factor. 2 halves is a type of conversion factor. And then what would we multiply pi over 2 by? 3/3, another conversion factor. You might have not thought of it that way in the past, but that's what it is. And so what do you get? You get, if you multiply straight across, you get 3 pi over 6. Let's put everything over 6, though. Since it's going to be in terms of the common denominator, we don't have to write down 2 separate fractions anymore. 3 pi minus 2 pi all over 6 if we combine it all at once, right? You combine the numerator, keep that common denominator. Does everybody see why I did it that way? And then, of course, you could skip this step and say what? Pi over 6. So what we're saying then is pi 6 plus pi thirds has got to add together to be pi halves. That's the complement, right? What would you do to get the supplement of pi thirds? Sup? So pi minus pi thirds. Well, since it's pi over 1, hopefully that's a little even quicker, isn't it? So the common denominator has to be the other denominator. 3, you can think of then as pi as 3 pi thirds. Probably do it in your head. What's 3 pi thirds minus pi thirds? 2 pi thirds. Does everybody see how I got that? So that's the supplement.